11.4, Binomial Probability. Now, when do we use the binomial probability? There's 4 conditions that must be met for us to use it. We have a fixed number of trials, and each trial only has 2 outcomes. A success or failure. The probability of success is the same every trial. And the trials are independent of each other. And so we're given the formula. Probability of X is the combination of n choose X, P to the X, and Q to the n minus X. What does this mean? In this case, n is the number of trials X is going to be the desired outcome. P is the probability of success, and Q is the probability of failure. So let's do an example. Find the probability of obtaining exactly 3 heads, so exactly 3 heads in 5 tosses of a fair coin. Well, what is our n? Number of trials, which is 5. What is our desired outcome? Exactly 3 heads. What is our probability of success? Since we're using a fair coin, it's going to be 1/2, and our probability of failure is also going to be 1/2. So when we're doing this, it's going to be 5, choose 3, and then from the probability formula, it's going to be P to X and then Q to n minus X. And then when we work this out, it's going to be 5 factorial over 3 factorial times 5 minus 3 factorial times probability of success times Q, which is also 1/2, times 5 minus 3. And then this is going to leave us with 5 factorial. So it's going to be 5 times 4 times 3 factorial over 3 factorial times 2 factorial. And then these cancel out, times 1/2 over to the third with 1/2 squared. And then we are left with 10 times 1/8 times 1/4. And we're left with 5 over 16, which is our binomial probability formula. Let's do another example. Find the probability of obtaining exactly 2 5s in 6 rolls of a fair die. So we want exactly 2 5s in 6 rolls of a fair die. So for our n, it's going to be 6 trials. For our x, it's going to be 2 because we want 2 successes. Probability is going to be 1 over 6 for getting a 5. And the complement of that is simply going to be, so Q is going to be equal to 1 minus 1 over 6. So it's going to be 5 over 6. And then we do the formula again. So 6 choose 2 times p to the x times q to the n minus x. That's going to be 6 factorial over 2 factorial, 6 minus 2 factorial times 1/6, 2 times 5 over 6, n minus 2, which is going to be 4. And then when we calculate this, we're going to get 3,125 over 15,552. And that is approximately 0.201, which is our binomial probability for this. So let's do another example. A couple plans to have 5 children. Find the probability that they will have more than 3 girls. So there's going to be 2 cases. They either have 4 or they either have 5. Find the probability. In each of these cases, there's going to be 5 trials. For P of 4, it's going to be 4 desired outcomes. Probability of having a boy or probability of having a girl is going to be a half. Same with having a boy. In this case, it's also going to be 5 trials. X is equal to 5. P is equal to 1/2. Q is equal to 1/2. And we want to find the probability that they will have more than 3 girls. So in the end, we're going to do P of 4 plus P of 5. Let's tackle one at a time. So P of 4 is going to be, when we do the formula, 5 factorial over 4 factorial, 5 minus 4 factorial, times 1/2 multiplied by x times 1/2 n minus x, which is just 1. And then P of 5 is going to be 5 factorial again, 5 factorial over 5 minus 5 factorial times 1/2 to the x, which is 5, times q n minus x, which is 0. And then when we work these problems out, P of 4 is going to be 5 factorial over, so 5 times 4 factorial, 4 factorial. These cancel out. Times 1 over 2, 4 times 1. And then P of 5 is going to be 5 factorial over 5 factorial. 5 minus 5 factorial, these cancel out. And remember, 0 factorial is always equal to 1. So this is going to be 1 over 1 times 1 over 2 to the, and then 1/2 to the 0. So in the end, we're going to be left with 5 times 1 over 16 times 1 over 2 plus 1 times 1 over 32 times 1. It's going to be equal to 0.1875. So another example. A pitcher who is also an excellent hitter has a well-established career batting average of .300. Suppose that he bats 10 times. Find the probability that he will get more than 2 hits in the 10 at-bats. Now, this experiment involves 10 trials. And we're asking, find the probability that he will get more than 2 hits. So they're asking us to find x equals 3, x equals 4, so on, until we get to x equals 10. Well, from our previous example, we had to add the probability of getting four girls or 5 girls. And in this case, we have to add as well for all 8 different possibilities. Well, that can be quite tedious. What we can do instead is get the complement, which is probability of him hitting less than or equal to hits. And so then our possibilities are going to be 0 hits, 1 hit, and then 2 hits. So when we're doing the complement, it's going to be 1 minus the probability x is less than or equal to 2. And this is a lot easier than having to compute this entire thing. So let's do it. 1 minus, and we have to do the formula for all 3 cases. So 1 minus p of x equals 0 plus p of x equals 1 plus p of x equals 2. And so we can compute that. So for x equals 0, we will do 10 factorial, because remember we have 10 at-bats. It's going to be 0 factorial 10 minus 0 factorial times the probability of hitting at-bat is 0.3. So 0.3 to the x, which is 0, times the probability of failure is going to be 1 minus the probability of success. In this case, it's going to be 0.7. N minus x, which is going to be 10, plus, and we do it for the rest. So 10 factorial over 1 factorial, 10 minus 1 factorial times 0.3 to the 1 times 0.7 to 9. Then we'll do it one more time for 2 at-bats, for hitting the ball twice. So 10 factorial, 2 factorial, 10 minus 2 factorial times 0.3 times 0.7, 10 minus 2, which is 8. And then when we compute the entire thing, it's going to be 0.0282 plus 0.1211 plus 0.2335. And then remember, this is still 1 minus this. So when we simplify, it's going to be 1 minus 0.3828, which is equal to 0.6172. And this will be the probability that he hits more than 2 times at bat for 10 trials.